right. Okay. Hi everyone, I'm Leilani. I'm part of the team. We're going to kind of jump into a different category of our project. So what we did is basically using the data that we collected from the audits, we were able to benchmark the Kalanhi facility using an Energy Star tool. Melvin, are you clicking? Okay.
Nice job on whoever set up this remote clicking thing.
Wait.
Wait. Oops.
Okay.
I think you need to go back like 4. Here we go. Okay. So Energy Star. For those of you who are not familiar with Energy Star,
I think you clicked the right. Did she click the right button to go forward?
Left click.
Okay, there we go. So Energy Star is a certification of buildings for excellence in energy efficiency and indoor environmental concerns. And this is granted through the EPA, or the Environmental Protection Agency. It's essentially like a score or a report card for how efficient and environmental your building or campus is. And in order to qualify, you first have to meet these 5 criteria: energy efficiency, thermal comfort, adequate ventilation, illumination, and indoor air pollutants. So we'll go into each one of those individually. Energy efficiency is basically the score given on the portfolio manager tool. And this is rated according to energy use intensity, which I'll talk about a little bit more later. Thermal comfort is the second criteria, and this is given according to the ASHRAE, or American Society of Heating, Refrigerating, and Air Conditioning Engineers. And it states that the temperature has to be between 68 and 78 degrees Fahrenheit, and the relative humidity is between 30 and 60%. And then there's adequate ventilation, another ASHRAE standard, 20 cubic feet per minute per person. And these are all things that engineers have to do. So our experience here is pretty limited.
There actually has to be a professional engineer that can white stamp this in order to have it.
Yeah, this is done by a certified engineer. And then illumination, according to the Engineering Society, says the lighting must be between 300 and 500 lux. And the last criteria is air pollution. It has to be acceptable according to ASHRAE, so no exhaust, smoke, mold, mildew, things like that. And in order to rate or get a rate on the building, we use the online benchmarking tool, which is called Portfolio Manager. And this tracks the water and energy usage of the building. The requirements for online benchmarking are first the year built, the physical address, and buildings are categorized according to location and also building type. So school buildings will be categorized with other school buildings. The total square footage. This is important because the calculation is the kilowatt hours divided by the square footage, and that's how you get your energy usage intensity. The number of full-time occupants, just how many people are in the building, and the current energy bills. This should actually be less, not more than 120 days old. And then the score is given by the EPA. The online benchmarking tool has an internal calculator, and it's on a scale from 1 to 100. And most of the buildings you can see on this curve are between 25 and 75%. So anything in the 25th percentile is deemed energy efficient. So again, according to type, then it's assigned a score dependent on the EUI. And EUI within the top 25 receive energy efficiency recognition by the EPA. So now we see Kalanhi High School. They actually scored an 84 for the EUI, which is, it's excellent. Yeah, it's really good. So they're doing a really good job in that category. And there are other categories that we look at. So energy efficiency is one. So they're good. Thermal comfort didn't quite get there. And this is because the temperature was too high, but mainly because the relative humidity was above 30 to 50%. Illumination, as you saw in the previous slides, most of the classrooms are overlit. And then these two, since we don't have any certified engineers in our team, we weren't able to conduct these studies. So, 1 out of 3, energy efficiency, right? So, doing good. Illumination, as I said, didn't meet that requirement. As you can see in the illumination chart here, this yellow bar is where the classrooms should fall, and most of them are outside of this region. I think, what is this, E building? E building has the best, or the most consistent lighting. Thermal comfort. Temperature was actually okay. On an average, it was below 78%. Although some of the buildings reached over 80, 85. So a lot of variations in temperature. But the main concern was, again, the relative humidity. So that was always greater than 55%. See here, it barely reaches. This is 55%, which is the upper limits of the ASHRAE standard, and this is where most of the humidity is, within the 60 to 70% range. And again, we haven't looked at the adequate ventilation or indoor air pollution. That's something we could recommend. Other recommendations are delamping to bring the lighting levels down. That's an easy solution. Another recommendation is to install more fans to increase airflow, which has also been shown to reduce humidity. When there's proper ventilation, the airflow reduces the humidity. And that's it for Energy Star.
And that's it for our presentation too, I think. Yeah.
Is that it?
Yeah, I think so.
That's just the extra lighting.
Want to look at more? Yeah. So that's everything that we had to present on from the report. Obviously the report has more information.